Is your Matplotlib trash? Well, that's hard to say, but I can show you how to improve almost any data visualization, which is what we're here to talk about today. But first, there's always so much to talk about when we are discussing Matplotlib, and I will say this. Most Matplotlib is trash. And that's no diss to the tool itself, but your Matplotlib might not be trash, but I'm willing to bet that there are a lot of knobs that you can turn in Matplotlib that you didn't even know existed. Don't get me wrong, tools like Seaborn or even Pandas plotting that add high-level abstractions on top of Matplotlib, they're fantastic. Until there isn't a specific method or a specific argument that moves that text annotation just a few millimeters to the left and you can't get it to line up the way that you want it to, and you end up having to search through documentation or going to StackOverflow hoping that somebody had the same question as you, or in the worst case scenario, you actually have to read source code. Well, today I am here to show you a couple of those knobs that have repeatedly come up across my path when making data visualizations in Matplotlib, and how we can use them to take your plots from trash to treasure. Let's go ahead and look at our base data visualization. I hope you look at this, and well, maybe your first instinct isn't, well, Cameron, that Matplotlib is trash. Maybe you might say, what am I looking at? And if you're creating a data visualization, it should really speak for itself. You should be able to look at this and figure out, okay, what are the data that are being represented and how is it being represented? I can see here that the title tells me that revenue of products and services, and then my eyes are immediately drawn to the legend here. And I can see that maybe this is a company, a multinational company that has a lot of different arms and branches. They offer quite a variety of products and services, from agriculture, furniture, software, all the way to perfumes, soaps, food, and kitchen appliances. And now let's take a look at the actual visualization itself. I can tell that we have a lot of bars here. Of course, this is a stacked bar chart, so that's going to make certain types of inferences quite challenging. I can take away two main things from this plot. Actually, three. On my y-axis here, we have revenue in millions of dollars, so I can tell that this company's making probably a good amount of money. But I can tell that around, or for each of these X ticks, whatever they might be, I can see that the total revenue kind of hovers around $75 million or so. You see we go up in these first three ticks, and then it kind of hovers at that value. The other inference I can draw from a stacked bar chart is I can actually compare the heights of these bottom-most bars to each other, and I can tell you confidently that whatever branch blue represents, whatever product or service that this shade of blue represents, it is increasing as we move to the right along our x-axis. And I still can't tell what that x-axis is. This is the output of just pandas.plot.bar with this option stacked equal true. And I see this all the time where you create stacked bar charts and then you have 12 or 13 different categories, and if you're not careful, especially with your colorization of your category selection, you end up actually with repeated categories. And so you can see here that I have a blue rectangle representing kitchen appliances, but also have a blue rectangle representing agriculture. And there's no way for me to figure out which blue rectangle here is on the bottom, if that's agriculture or kitchen appliances, versus which blue's on the top here. And so whenever you're making a stacked bar chart, which I would probably just recommend not making a stacked bar chart because it makes inferences from anything besides the bottommost bar almost impossible. If I want to compare the heights of these orange bars to each other, I have to squint and draw a lot of parallel lines in my head to say, okay, this orange bar, that's about 10 in height. This orange bar, I think that's about 10 in height. This orange bar is about 10 in height. And I keep going all the way down. I'm like, is this orange bar, is it changing with respect to our x-axis? And you have this question for every single category. And I hope you're thinking, well, maybe it's because we don't want a stacked bar chart at all. What we really want here is just a grouped bar chart. And you look at this and you're just left with this same kind of feeling. In order to figure out, I can very clearly see that my blue is increasing, and I can see that slight shifts in my orange occurring. But all of a sudden, when you start looking down here, all these colors start bleeding together. Everything is a little confusing and a little overwhelming to look at because you're not sure where to direct your attention. Do you go and compare the orange bar to the next orange bar to the next orange bar? Or do you try and compare the blue to the orange bar, the brown to the orange bar, and make those within X-tick comparisons? So, since that is our base data visualization, let's see how we can make it just a little bit better. Now, the first thing I will always recommend is instantiating your own figure and axes objects to control your plotting. This will give you very fine-grained control over what you pass down, and if I still want to use the convenience of pandas plotting, I can do that. However, I now can pass my axes in as the thing to be drawn on. And so when I go ahead and plot this, you'll see I've actually made 0 changes, but I've just changed up the way I'm using the API just a little bit. If I want to fix this up just a little bit, the first change I always make is using the RC function in Matplotlib. And what this does is it controls or helps us control some global Matplotlib settings in the RC parameters. And you can see here that I'm dictating the font, which is defaults to a base of size 12. I'm just going to bump that up a little bit to size 14 because I found that a lot of our text was quite small. And now that I've increased our text, go on and I'll actually increase the DPI, the dots per inch. This will have a synthetic effect of actually increasing our font size further, but it actually increases the size of everything on our plot just by a little bit. And this defaults to 100, so setting it to 150, we get quite a large blown up plot here. But you can see that my X-ticks are still quite a disaster. The next thing that I think is absolutely unnecessary on almost every plot is this border. You see this very large border around my entire plot. We have this top line and this right side line that dips right behind my head. These are called spines in Matplotlib, and you can actually control these from a global setting, or you can access them on the axes object itself. And so I can just go ahead and quickly turn those off. And you see that now all I need to worry about is my left-hand spine, which is actually where my Y ticks are, so I'll keep that. And I think we're ready to really just get all of this text on the screen. I'm tired of not being able to see my X-tick labels. And so what we can do is, if you ever Google, how do I get everything on my screen in Matplotlib, you'll find some Stack Overflow answer that says, oh, just call plt.type_layout or fig.type_layout, which I would recommend using the object-oriented interface. And what this does is it evaluates all the space that all of the artists on your figure, which is your sheet of paper you're drawing on, and it'll actually resize everything just to make it all fit on the screen. And you can see that the labels on my x-axis that Pandas gives me by default are absolutely horrible. And so if I want to fix that, I can now see based on the data analysis that this is actually quarterly data, and we're just grabbing the end date of each of these quarters. So this would be 2000 Q1, the end of March. This would be 2000 Q2, Q3, and so on and so forth. And so what I can actually do in order to have a little bit of control over that is I can come down here to my X-tick labels. I can actually grab the text out of my X-tick labels, and I could do this with the pandas index and just set my X-tick labels from there. But I can grab the text out of my X-tick labels, I can convert those to a pandas date time, and then I can actually convert all of these to a quarter, or to a quarterly basis. And so when I do this, you see that I have 2000 Q1, 2000 Q2, 2000 Q3, and so on and so forth. Now I'm not loving I have way too much extra space here now, so what I might want to do is actually move my tight layout command to the bottom of my screen here. And this actually resizes things a little bit better. Tight layout should always be the last thing you call before you actually display or save your figure, because that way it'll resize everything that's currently drawn on screen and nothing that was removed or not previous iterations of the drawing. The thing that I'm not loving here is, one, my legend is totally eclipsing the bulk of my data, or probably a quarter of my data here. And then I don't like having to turn my head sideways in order to read these X-tick labels. So let's go ahead and we'll fix the legend first. Now, one of the nuances that you need to be aware of when using things like pandas is that it'll expose a lot of options to you, and those options are convenient, but they take away some of your control over the plot. So if I actually wanted to have control over where my legend is placed, I would actually need to extract that from my Matplotlib axes and then reposition that. Or I can actually just tell pandas to not plot my legend, not have any control of my legend, and then I can actually create my legend manually because pandas sets up the labeling for me automatically. And you can see here that I'm going to position my legend so that the anchor point is on the center left, but the legend will appear on the center right of my plot as specified by my bbox to anchor here. 1 meaning all the way on the right hand side of my axes, 0.5 meaning halfway up vertically. And the center left controls where that point is, so we'll actually pinning the center left portion of my legend to the right hand side of my axes. And thank goodness I have that figure.tight layout that makes sure everything is nice sized and is able to be presented on my screen. The next thing that I'll do, I complained about, right, those X ticks being a little bit hard to read when they're vertical. Well, what I can do is I can actually set their rotation here, and I'll go ahead and show you what this looks like. Using the setP function, which stands for set properties, I can actually get all of my X tick labels and I can set a specific property that they have, which is their rotation. And now if I do this, it's currently defaulting to 90. I can set it to 25, I can set it to 0. And when I do that, well, you see that I can very easily make sense of which label goes to which, but now my labels are slightly overlapping. And so there are a number of ways that we can do this. One of the easiest is actually just not setting our rotation to 0, but setting it to 25. And then what we need to do in order to make sure everything lines up correctly is actually set our horizontal alignment. So where on the text are we rotating or aligning our text to? We're aligning the right side. And you can see that my text is starting to fall more clearly under each of the bars that they represent. The last thing that I like to touch up here whenever manipulating tick labels and rotating them, I should say, is to set a rotation mode. And there are 2 rotation modes. There's a normal rotation mode and there's an anchor rotation mode in Matplotlib. The difference here is that by setting the rotation mode to anchor, which is the non-default option, we're actually lining up the top corner of the text itself against the area that we're pivoting on instead of the corner of the text box. And so now you can see that my texts are more directly aligned with the bars that they're representing, and we get a little bit of a nicer picture for our plot. The last thing that I dislike about this plot, just aesthetically, and we'll get into the fact that there are just way too many categories here to plot in a minute, but these small little ticks down here are completely unnecessary. And if you're having trouble seeing them, I can go ahead and make them bigger for you. Right. I'm talking about those ticks at the bottom of my x-axis and just need to turn this back on. These bolded ticks down here. We can actually use one command called bottom equals false when setting our tick parameters, and that will completely eliminate them. For most categorical plots, having actual tick markers is a little redundant unless you're using them to separate the edges of your categories, not denoting the center of your categories. And so I tend to turn them off for plots or visualizations that are like this. And so we have cleaned up our stacked bar chart quite nicely here. I could, of course, add my Y label back in, add a more appropriate title back in, but I think this is as far as we can take the stacked bar chart. I already told you all that I don't really love stacked bar charts. It makes some inferences actually quite tricky. And so instead of the stacked bar chart, which is still trash, of course, I'm going to opt for something just slightly different. What I'm going to do here is I'm actually going to make not one chart or one plot, but many. I'm going to make as many plots as I have quarters in my data frame. And so when I do this, you can see that I now have one row of many plots. There's actually 1, 2, 3, 4, 5, 6, 7, 8, 9 plots here. And I'll go ahead and I'll turn this bottom spine back on so you can more clearly see what constitutes a given axis. And you can see that they're just very tall axes in this case. From here, what I like doing is I'll actually go ahead and iterate over my data frames, and I'm going to zip together, right, each of those axes objects. And by doing that, I can actually I can plot one row's worth of data on one axis. And I'm actually going to invert this because it's kind of, as I mentioned, it's a tall plot. There's a lot of data here. And I'm going to plot a horizontal bar chart in this case. And we've actually transformed this data quite largely. And I'll go ahead, let me fix this title for you. And so I've actually transformed this data quite heavily. We can see that instead of stacking all of our bars on top of each other, we're now offsetting that stacked position. And what this lets us do that the stacked bar chart did not let us do previously is I can very easily make within facet comparisons. This type of transformation is called a faceting. I've taken a color-coded categorical variable and turned it into a facet or a positionally encoded variable. And so now instead of Q1 being stacked on top of food, or kitchen appliances being stacked on top of food, stacked on top of soaps, we've just laid them out side by side. Now, as I mentioned, this lets me make comparisons within the quarter very, very easy. I can see that food is higher than soaps, which is just as high as perfumes, and I can see that agriculture is lower than furniture for Q1. It's still a little bit tricky to compare food from Q1 to food from Q2. However, I am more readily able to do this now than I was with the stacked bar chart. And this is mostly an exploratory visualization. And what I mean by that is we don't yet have a message. We're still understanding what is in our data to make something that's meaningful. And so when creating exploratory visualizations, it is good to faithfully represent the data that you have and make those comparisons across or within your data sets very easy. And so by eliminating the fact that I have offset bottom positions on my bar chart, really lets me easily compare within and to a smaller degree or lesser degree across the quarters. The next thing that I might want to do, you can see that my X tick or my Y ticks on the left-hand side of this plot or on the far side of this plot are cut off. I'm not going to use the tight layout trick, but instead I'm going to exert a little bit of manual control over my plot. And all I'm going to do is that I'm going to take that grid, that layout of plots, and I'm going to bring that left-hand side in by about 15% of its own size. And so when I do this, I'm actually able, just pulling this in ever so slightly so that you can see all of my Y-tick labels. And a fun little trick that I enjoy doing here is actually when you're plotting Matplotlib and using the graphical user interface, I can open up this handy widget, and I can actually shrink the left-hand side of my plot. And you can see that when I do that, and I change it to about 0.18, we're able to very easily see all of the labels that I have set on my plot. Moving on from there, the thing I don't love about this visualization is I'm repeating the year in my title a lot. These X-tick labels don't really have any meaning. I see 0 and then 200, and I don't have any references or any indicators for references in between that range, so it's kind of large. Seems that Matplotlib didn't pick the best defaults for us. It happens. And so let's see if we can reduce a little bit of the verbosity in this visualization. The first thing that I'll do is I'll actually collect the positions of each of these titles. And so I'm going to create a default dictionary collecting all of these axes objects. I'm going to combine them or group them by their year. And what I can do with this is I can actually iterate back over that list, and I can add a line spanning from the leftmost axes in a given year to the rightmost axes in a given year. And by doing this, I'm now visually grouping my axes such that you can very easily see one full year separated from the next full year, separated from the next full year. You can see that just by this thick line across the top. I can, of course, shrink that line width so it better matches up with the spines, but I actually kind of like it thick here because it provides a clear indication of the grouping of the years of my data. The next thing that I'll actually do is I'll actually spruce up those titles. And to spruce up those titles, I'm actually going to remove the very repetitive year. And you see this in a recent version of Matplotlib, they do have a concise dates formatter as well as an auto date locator that pair up quite well. And this is inspired by that type of setup. And so what I can actually do is I can take each of my titles, which I'll show you what look like right now since I just deleted the year. I have Q1, Q2, Q3, Q4, and those are the titles on each of those axes. I'm going to take each of those titles, and I'm just going to add another title that is offset, aligned to the top of the existing title. So I'm going to put something on top of Q1, Q2, Q3, Q4. But I'm only going to do this once per year. So with this change, you can now see that I have highlighted the year 2000, Q1, Q2, Q3, Q4, and I've reduced the repetitive labeling that I had on my plots. And this little trick is just decluttering, right? If you ever read about data visualization, you know of Edward Tufte, you know that the data to ink ratio is something that's very important. We don't want to over annotate or over label our plots with things that are not interesting. And so ideally, we want to use the least amount of ink to communicate some type of meaning, or in this case, some type of exploratory insight. And once we fix up those labels, like I said, the next thing that I want to actually spruce up will be those X labels. And just to show you what I mean, so we fix the titles up here. Now go into the bottom half of our plot, or the bottom of our plot. I mentioned that I see 0, and then I see 200, 200. Oh no, that's actually 20, 0 to 20. And the next 0 is just so close to it, it looks like 200. That's something we most certainly want to avoid because we might actually mislead someone there. And so in order to fix this, we'll have to play around with the X ticks. And what I'll do here is I'll actually iterate over all of my X ticks. I can do a few things here. I can, of course, do ax.setXticks and feed some type of manually created list. And when I do this, you see that instead of 0 and 20, I have nothing at 0, and then I just have 10 and 20. This is good for this data set. But if I'm trying to create reproducible workflows, if I want something that I can swap the data set, maybe take a different decade's worth of data and feed it through this and get a similar or the same type of visualization, 10 and 20 might not cut it. What if my company's profits or revenue, were not 10 in the 10 and 20 millions, but maybe just in the 1 and 5 millions? Maybe I just started my company a decade ago and we didn't have the revenue that we see now. Well, one thing that we can do is we can use a linear locator in Matplotlib, and this is from the ticker submodule. And all the linear locators, or all of the locators as a family, do is establish rules at which those ticks will be placed. And so what I can do here is take that linear locator and say, I don't care how you do it, but just give me 3 ticks along my x-axis. And that's what this 3 right here stands for. And you'll see when I do that, well, we have 3 ticks. We have 0, we have 10.1, and we have 20.1. And you can see that now my X ticks are just overlapping on themselves. How can I dial this down just a little bit and maybe get rid of the 0 completely, or maybe I can even just rotate these to 90 and just call it a day. But you see that even with rotating them 90, I can fix the horizontal alignment. I don't like having to turn my head to read a chart. So what we'll end up doing is, one of the things I really love doing is actually subclassing different locators from Matplotlib, and they all have this tick values method. And what tick values does is, given a minimum and maximum value, it'll calculate the positions of the ticks in between those. And so what I can do here is that I know that my minimum is going to be pinned at 0 based on the type of chart that I'm creating, which is a bar chart. And I know that my maximum is going to be some value that is derived from my data. What I can do is I can actually, in order to remove the 0, which is what I'll do first, I'll remove the 0, but just by returning all of the ticks it would have returned, but just take off the left hand one. And so now I don't have 0 as an X tick, I just have 10.1 and 20.1. But 10.1 and 20.1 are kind of funny to look at in a chart. Typically you want to see whole or rounded numbers, things rounded to 0 or things rounded to 0.5. And so what I'll do is I'll actually floor those X ticks. And so when I do that, we can actually come out to a nice rounded or a nice even 10.0, 20.0. To get rid of that, I'll just change the formatting supplied here to a general formatting, or I could have done floating with 0 decimal places. But you see that I create a fairly cleaner visualization to look at. And that's a little bit on the aesthetic side there. The last thing I'll probably want to do is just add a subtitle or superior title, something that sits on the top to explain what you're looking at. For communicative visualization, this would actually be what you should be looking for. And since it's just an exploratory data visualization, I've just kind of annotated what the whole chart encompasses. Now, if we were to take that same exact chart and say I want to convey something meaningful about the about the totals that we see here. Well, what I can do is I can take that same chart that we started with, this one right here, and I can actually squish it up just a little bit. And I'll lean into my grid spec keyword arguments here and set my bottom to 0.3. So now I've brought my left into 15% of my figure width, and I've brought the bottom up. And the reason I brought the bottom up is because I'm going to now do something with this space. I'm going to actually add another grid spec here, and I'll even show you what this looks like. So if I take that grid spec and I add in a bunch of subplots to it, you can see that I have just as many axes on the bottom as I do along the top. And I'll even show my spines so you can actually see just that. You can see I have exactly the number of axes on the bottom. Now, I'll get to that trick in a moment. The next thing that I'm going to do is I'll add a title to my bottom plot, because this is going to represent the total revenue from each of these quarters. So this will be the quarter total. And so I'll probably add that to my title here, quarterly total revenue. And in order to add this data, I'm going to again iterate over my quarters as well as the axes that I just created. I'm going to use a point plot here, or a lollipop plot. And you can see that when I use a lollipop plot instead of a bar chart, I'm trying to say these data are slightly different than the ones that you see above with the bar. So I now have a point that has the height that corresponds to the total revenue for that quarter. This lets me make the cross-quarter comparisons of my total revenue quite easily, whereas these bars did not let me do that quite easily. So now with this bottom chart, I'm focusing on the cross-quarter comparisons. And to clean this up, you can see that there's a lot of noise from all of these spines and these vertical spines on the left-hand side, as well as the bottom spines here on the right. And so what I'll do is I'll just clean this up a little bit. I'll iterate over all my axes, excluding the first one, and I'll remove the left-hand spine. I'll remove the left-hand ticks, and I will set my y-axis locator to every 25 points. And now you see, instead of just like 2 points on my y-axis, I now have 4 or 5. The next thing that I'll do is I want to create an illusion that this is just one set of axes. And you can see there's little gaps in my bottom spines here. What I can do is I can actually remove the width between all of the axes objects on this chart, or in that specific grid layout, by setting this W space parameter to 0. Now it looks like this is just a single axis, and it's in fact not, because the alignment is tied to the set of bars above it. So now we've perfectly aligned 2000 Q1 to all of these bars that are also labeled 2000 Q1, and we can look at the breakdown of revenue as well as a comparison of the total revenue. And this is how I would take this specific data visualization from trash to treasure using Matplotlib and many of the knobs that it has to offer. Now, I'll admit, I don't think we ended with a perfect data visualization here. We ended up with something that allowed us to better explore and compare our data, which is great, but we have yet to derive a specific meaning. And this is a topic that I would love to get into next time when we discuss data communication and how we can go from an exploratory visualization to a communicative visualization. A few things that I think we could improve on here. The default typography in Matplotlib isn't that great. So if you are a fanatic over choosing different fonts and things like that, you can use Matplotlib and you can actually clean up the typography on these visualizations quite nicely. And the next thing is, I think this plot, if I were to actually be sharing this with someone else, it's a little bit plain looking. I would play around with colors on the background figure, colors of the bars, and maybe I would even color code these bars to some type of categorical palette so you could very easily see that kitchen appliances changes over time. Thank you everyone for watching. I hope this has been valuable to you and that you will join us for another session in the future. Thanks everyone.